All right, last section. So 7.4, similar triangles. Two triangles are similar if one of the two following requirements is true. If we have any two of the three corresponding angles are congruent, remember congruent just means equal. And it's not everyone, so we only have to check two of the three. So any two of the three corresponding angles are congruent. And one pair of corresponding angles is congruent, and the corresponding sides adjacent to these angles are proportional, right? So if we have two angles that are the same in a triangle, then we know that they are going to be similar. So there's always 180 degrees for the interior angles of a triangle. So if you have two of the same, you know that last one is going to be the same angle, which means all of your angles are the same, which means you are going to have a proportional shape, right? And same thing over here. So if I have an angle and the two adjacent sides, so if I have a side, an angle, and then another side, so SAS, okay, then I'm going to have similar triangles as well. Okay, so if I know two angles, then I know they're similar. And if I have a side and then an angle and another side, so like this, then I know that my triangles are similar. Okay, so 13 and 26, so multiply by 2, those are proportional. 8 to 16 by 2, so proportional sides, and the angle of 92 is the same. Okay, so are these two triangles similar? Well, here I'm given an angle of 84 and 62, and here I'm given an angle of 84 and 34. Right, so it doesn't really look like it's similar, but I was not given corresponding sides. So let's take a look here. So let's do 180 minus 84 minus 62, and we get 34 degrees. So this angle appears 34 degrees. So triangle 1 has angles of 84, 62, and 34. Now, without even knowing, if I do this again, 180 minus 34 minus 84, well, since this one was 34, I know that this last angle is going to be 62 degrees. So these two triangles are similar. So triangle 1 is similar to triangle 2. So for example true, we have triangle ABC is similar to triangle XYZ, and we want to find the length of the indicated side, and we're going to round to 1 decimal. So taking a look at our triangle, these are similar, so we can look at the proportions, which means we can set up a ratio. Okay, so I have 6 centimeters corresponds to X. Okay, so 6 centimeters corresponds to X divided by, so 5 centimeters corresponds to 1.25. So 5 centimeters and 1.25. Notice here I have all of triangles ABC, and here I have triangle XYZ's information here. And then these are our corresponding sides. This way and this way. So make sure you're setting it up correctly. Now just doing this proportion. So we'll divide by the one across from the thing we're looking for, and here we go. So 6 times 1.25 divided by 5. Get X equals 1.5 centimeters. Right, we can on. So given the following diagram, solve for X, show your work. Hint, break this up into 2 separate triangles so that we can see which sides are similar, because right now it looks kind of confusing because it kind of looks like, you know, this weird shape here and this triangle here. So I got a quadrilateral and a triangle. All right, so let's make this big triangle and this small triangle. So this big triangle, hey, caramba, here. So this is ACD. So here's ACD. And I know this side right here is 20. And this side right here is 6 and 10. So 6 plus 10, I get this side is 16 long. right? So I have this is 20, this is 16. Taking a look at this smaller triangle, yeah, okay, here we have x. So the smaller triangle is ABE. This side is an x, this side is a 6. So now it's a little bit easier to see where my corresponding sides are. So here I have 16 and 6. So let's set it up like so. So I have 16 over 6 equals, and then 20 over x. Right? So it doesn't matter how you set them up as long as, okay, so here, so the 16 and 20 are from the same triangle, the 6 and the x are from the same triangle, and this time we have our corresponding sides like this, 16 and 6 and 20 and x. So it really doesn't matter. I usually like to set them up kind of how they look. So if I take a look here, 16 and 6, 20 and x, and then I set them up kind of like that, so equal each other. It's completely up to you. If you want to keep it triangles this way or and corresponding sides this way, you can do that too. But remember, with proportions, it doesn't matter as long as you've set them up correctly. All right, so taking a look at solving this. So here is the thing I'm looking for. So you divide by the one you're looking for, and the other two get paired up happily. So 20 times 6 divided by 16. And we get x equals, oops, 7.5. What am I writing? So x equals 7.5. Good. All right, so you can go on to your similar triangles assignment and then on to your review, and then you're ready to write your test. All right, bye.